Let's look at the sum and difference of cubes formulas, and then we'll look at some examples of factoring these expressions. A cubed plus b cubed factors to a plus b times a squared minus ab plus b squared. And the difference of two cubes, a cubed minus b cubed, factors to a minus b times a squared plus ab plus b squared. So for example, if I have x cubed plus 8, this is the sum of two perfect cubes. And I want to ask myself, what cubed is x cubed? Well, x cubed is x cubed. And what cubed is 8? 2 cubed is 8. So here for our formulas, a is equal to x and b is equal to 2. Now we'll substitute into the formula. We have a sum of two cubes, so I'm writing down that formula. A plus b times a squared minus ab plus b squared. And we know a is x and b is 2, so we'll substitute in. So in the first parenthesis, the linear factor is x plus 2. In the second parenthesis, a squared, we're going to substitute in x squared minus a times b minus x times 2. And normally we rearrange it and put the coefficient in front, so minus 2x. And then plus b squared or plus 2 squared. 2 squared is 4. So our quadratic factor is x squared minus 2x plus 4. So the sum of cubes, x cubed plus 8, factors to x plus 2 times x squared minus 2x plus 4. Example 2. Here I've got 8x cubed minus 27. And I didn't mention it, but we should always, of course, look to see if there is a greatest common factor that we can factor out first, but we don't have any here. But I do have a perfect cube minus a perfect cube. What cubed is 8x cubed? 2x to the third power is 8x cubed. And what cubed is 27? 3 to the third power is 27. So here a is 2x and b is 3. This is a difference of cubes, so we'll use the difference of cubes formula, which says it factors to a minus b times a squared plus ab plus b squared. So let's substitute in 2x for a and 3 for b. So our linear factor is 2x minus 3. And then for our quadratic factor, you'll have 2x squared plus a times b, 2x times 3, plus 3 squared. And we'll simplify that. So 2x minus 3 stays the same. 2x times 2x is 4x squared. 2x times 3 is 6x. 3 squared is 9. So our quadratic factor is 4x squared plus 6x plus 9. So these quadratic factors that we get from using the sum and difference of cubes formulas are not factorable. So otherwise we would have tried to continue factoring. But these are our factors, the factors to a linear factor and a quadratic factor. Let's look at one more example. Example 3, 256x to the fourth minus 4x. So is there a GCF? Well, I can factor 4x out of both of these terms. When I do that, 256x cubed divided by 4x is 64x cubed. Negative 4x divided by 4x is minus 1. And now in parentheses, I have the difference of two perfect cubes. So what cubed is 64x cubed? 4x to the third power is 64x cubed. And what cubed is 1? 1 to the third power is 1. So here my a is 4x and my b is 1. This was a difference of two cubes, so I'll write that formula, which is a minus b times a squared plus ab plus b squared. I'll get back to that original GCF that we originally factored out in a moment. So a minus b, I'll substitute in 4x for a and 1 for b, and I get 4x minus 1 is my linear factor. And then we'll substitute in 4x and square it for a squared, plus 4x times 1 plus 1 squared. And we'll simplify that second parenthesis, so 4x minus 1 stays the same. 4x times 4x is 16x squared. 4x times 1 is 4x. 1 squared is 1. So our difference of cubes factored to 4x minus 1 times 16x squared plus 4x plus 1. But remember, we originally had a GCF of 4x. So this original expression factors to 4x times 4x minus 1 times 16x squared plus 4x plus 1.